Can you solve this set theory puzzle that 90% of college students fail to understand? Don't go away, because by the end of this video, not only will you master it, but you'll also understand 5 problems that will completely change the way you think about math. Hi, I'm MathVare. Welcome to the channel where math becomes super easy. Today we're going to solve step-by-step 5 challenging set theory problems that will make you shine in your exam. And please, if this content helps you, give it a like. And subscribe for more content like this. We start with our first challenge. We have set a defined as all values of x, where x squared minus 1 equals 0, and set b where x minus 1 squared equals 0. First, let's solve a if x squared minus 1 equals 0, then x squared is 1, which means x is plus or minus 1. Therefore, A is the set containing negative 1 and 1. Now B, if x minus 1 squared is 0, then x minus 1 is 0, so x equals 1. Therefore, B is the set that contains only 1. Do you see the relationship? Since every element of B is also in A, we can conclude that B is contained in a perfect. Now comes the true or false challenge. Given A equals the set with 1, and B equals the set with 1 and 2, let's analyze these statements. Is A contained in B? True, because 1, which is the only element in A, is also in B. Is it properly contained in B?
True,
because A is contained in B, but they're not equal. Is A an element of B? False. Here's the key. A is a set, not an individual element of B. Is 1 an element of A? True. 1 is indeed inside. Set A is 1 contained in A. False, because 1 is a number, not a set. Remember, element of is different from contained in. This distinction is super important. This problem is fascinating. We have a equal to the set with 1 and be equal to the set that contains both the set 1 and the element 1. Attention. B contains 2 different things, the set 1 and the element 1. This is what makes this problem so interesting. Is it contained in B? Yes, because the element 1 from A is in B. Is A an element of B? Also yes, because the set 1, which is exactly A, is an element of B. This is a perfect example of how a set can be both a subset and an element of another set. Here comes the full challenge. For set S, with elements 1, 2, 3, 4, we need to find all its subsets. Remember the magic formula. For a set with n elements, there are 2 raised to the n subsets. With 4 elements, we have 2 to the 4th, which is 16 subsets. Let's organize them by size. Size 0, only the empty set. Size 1, the 4 sets with 1 element each. Size 2, the 6 sets with 2 elements. Size 3, the 4 sets with 3 elements. Size 4, the full set. Do you see the pattern? Each element can be in or out of the subset. 2 options. Per element, that's why to raise to the n. For our final challenge, let's analyze these complex relationships. We have a equal to 1, 2, which contains numeric elements. B equal to 1, 2, which contains sets as elements. C equal to 1, 1, 2, which also contains sets. And D equal to 1, 2, 1, 2, which contains all these sets. It's an element of C. True. Because the set 1, 2, which is exactly A, is inside C as B, contained in D. True. Every element of B is also in D. Is it contained in B? False. A contains numbers, B contains sets. They're completely different types. Incredible. You've mastered 5 challenging set theory problems. Always remember the key difference is an element of versus is contained in. If this video helped you understand set theory better, give it a like, share it with your classmates, and subscribe for more math content that will make you shine in your exams. And here's your bonus challenge. Can you find all the subsets of the set A, B, C? Leave me your answer in the comments. See you in the next MathVare video where math becomes super easy.